Morning, guys. I wanted to try to go over the study guide with you guys before the midterm. So we'll start with just adding vectors in I, J, K hat format. So each one of these is representative of a unit vector in either the x direction for I, the y direction for j, the z direction for k. If we're adding them in this format, we're going to combine like terms. So I have 4i and negative 5i. So 4 plus negative 5 is going to give us negative 1. So that's going to be my I hat component. Then our j hat, which represents a vector in the y direction, is going to be 5j plus 6j, which is going to give me 5 plus 6, which gives me 11j hat. And then finally, our positive z is going to be 2k plus 7k. So 2 plus 7 is equal to 9k hat. I feel like I'm too much in the dark on this. All right, so to subtract a vector would be to add its opposite. So we have D is 4i hat plus 5j hat plus 2k hat. E is negative 5i hat plus 6j hat plus 7k hat. So I can either just subtract each term, or I can rewrite this as its opposite. So negative 5i hat would become positive 5i hat. 6j hat would become negative 6j hat, and positive 7k hat would be negative 7k hat. And so then when I add the components, my I hat component would be 4 plus 5, which is 9 I hat. I would have 5j hat plus negative 6j hat, which would be negative 1j hat. We don't have to write the 1 in there. And then for my k hat, I would have positive 2k hat minus 7k hat, which would be minus 5k hat. All right, to find the magnitude of these vectors in 3 dimensions, our added step is that we're just going to have an extra square term. It's as easy as that. So just like when you found the length of a hypotenuse of a right triangle, we knew the two sides, we're doing the same thing, but it's just in 3 dimensions. So in the case here where we have a vector in coordinate form that's 1, negative 2, comma 3, the magnitude of it, the length of how long this vector is going to be, would be the square root of 1 squared plus negative 2 squared plus 3 squared, which is radical 14. So our example here, again in our coordinate form, we have 5 comma negative 6 comma 3. If I want to find the magnitude of this, which we write with the absolute value bars, just tells us we're looking for the length of the vector, is going to be the square root of 5 squared plus negative 6 squared plus 3 squared, which ends up being 8.37. We also have vector cross products, so this is going to be vector multiplication of 2 vectors that results in a third vector that is perpendicular to each of them. So our example from physics would be torque or angular momentum. For this, you need to set it up so that you have your I hat, j hat, and k hat components. We have A is 3 I hat plus 2 j hat plus 4 k hat. B is I hat plus j hat plus k hat. Again, since there's no number in front of this, this is a 1. If it were a 0, it just wouldn't be there. All right, so I'm going to have 3, 2, 4, 1, 1, 1. Okay, so for the I hat terms, our rules are we cover up this column, and then we take this diagonal minus that diagonal is going to be our I hat. And that's because j hat cross k hat is I hat. So I'm going to take 3 times 1 minus 2 times 1, which is going to give us, I'm taking 2 times 1 minus 4 times 1, covering up the wrong thing, huh? So I'm going to have 2 minus 4 I hat, which is negative 2 I hat. The j hat one, because of our right hand rules, when we figure out the direction, if you guys remember, we put our fingers in the direction of the first vector, we curl our fingers towards the second vector, and our thumb tells us the direction of the third vector that we're creating. The j hat one is backwards. So for the j hat, and I'll switch colors for this, instead of taking our diagonal down and to the right, it's going to go in the opposite direction for our j hat terms. So I'm covering this up, and instead of going 3 times 1, I'm going 4 times 1 minus 3 times 1. So I'm going to have 4 minus 3 is my j hat, which just gives me a j hat term. And then again, we go back to the same way we did with the I hat, with the k hat. I cover up that column. I'm only going to have results for ones that are perpendicular. So k hat and k hat are parallel. They won't have results. And then this is going to go the same way as we did with the I hat. So covering this up, I have 3 minus 2, which just gives us k hat. All right, now to find the magnitude of this vector cross product, I'm just going to take the square root, so I can put A cross B, magnitude is just going to be the square root of each of the terms. So I have negative 2 squared plus 1 squared plus 1 squared, and this gives us radical 6. So that's the length of this three-dimensional vector. All right, so they can also give these vectors to us in our coordinate form. So if I have A is 2, 3, 4, that's the same as 2i hat plus 3j hat plus 4k hat. Again, we're looking at A cross B. I'm going to set this up so that I have I, J, K, and then since it's A cross B, it's going to be 2, 3, 4, 5, 6, 7. A cross B and B cross A are not the same thing. So even though they have the same terms, they don't end up being the same thing. So for the I hat, I'm covering this up. I'm taking this diagonal minus that diagonal is my I hat. So I have 3 times 7, that's 21. 4 times 6 is 24. And I have negative 3 I hat. Again, j hat flips it because of our right hand rule. So I'm going to go in the opposite direction. I'm going that way minus that way is my j hat. So I have 4 times 5 is 20, 2 times 7 is 14, and that gives me 6 j hat. And then k hat goes to the original way, which is going to be 2 times 6, which is 12, minus 3 times 5, which is 15. So that is going to give us negative 3 k hat. If I want to get the magnitude of this cross product, it's going to be the square root of the squares of the terms. So I have negative 3 squared plus 6 squared plus negative 3 squared, and this ends up being 7.34. That's just giving us the length. Another example in coordinate form of our vector cross product, we're going to do A cross B when A is 2, negative 5, 1, and B is 3, negative 2, 4. Again, I'm going to set this up in my I hat, j hat, k hat component way, I have to put A first because the order matters. And then again, I'm going to cover this up, and I'm going to take -5 times -4, which is 20, minus 1 times -2, which is -2. So 20 minus -2 is 22. Again, my j hat is going to go in the opposite direction because of our right-hand rules. So I have 1 times 3, which is 3, minus 2 times -4, which is -8. So 3 minus -8 is 11. And then for my k hat, I go back to the original way of going this diagonal, which would be 2 times -2, which is -4, minus -5 times 3, which is 15, -4, minus a -15 is 11. Our magnitude again would just be the square of the terms square rooted, which ends up being 26.9. And for your midterm, this will be multiple choice, and I believe I left them all as radicals. I didn't put them in decimal form. All right, on to the second page. If we're given the vector and they want us to express it in either of the forms, I can look at the components of it on the grid. So A, if I look at A in the I hat direction goes -1, -2. So my x component would be -2. In the j hat direction, the positive y hat direction, or positive y direction, it goes 1, 2, 3, 4, 5, 6. So I would have -2, 6. B, we can express similarly. If I do this in the I hat, j hat, this just means it's -2 I hat plus 6 j hat. Because these are unit vectors in the positive x direction, the positive y direction, so making it negative makes it go in the negative x. For B, I'm going to count over 1, 2, 3, 4, 5, comma 1, 2, 3. In our I hat, j hat, k hat format, this would just be 5 I hat plus 3 j hat plus 0 k hat. So you don't have to write the one that there isn't a term of. And usually we use this only in 3 dimensions. If it's just 2 dimensions, then you don't really need to worry about that. All right, the magnitude of A is going to be the square root of the square of the terms. So I have 2 squared, which -2 squared, which is 4, plus 36, which is 40, the square root of which is 6.16. The magnitude of B is going to be the square root of the square of the sums, which is 5 squared plus 3 squared, square rooted, which is going to end up being 5.83. The other multiplication that I showed you guys was the vector dot product. So that's the combination of 2 vectors that results in a scalar. An example would be work. So work was force times distance parallel, so you only combined the parallel components. They want us to find A dot B. A dot B is going to be equal to AX BX plus AY BY. So you're only combining the terms that are parallel to each other. So for our x components, we would have -2 times 5, which is going to give us -10. and then I'm going to add this together. My y components would be ay, which is 6, times by, which is 3, which is 18. So that gives us 8. And so there's no directions associated with this. Again, the example from Newtonian mechanics would be work, which is expressed in joules, which is a scalar. All right, the same thing with these two vectors. They just want to have a little bit more practice. In component form, for A, I would have -1, -2, -3. -1, -2. So 3, comma, -2. In our I hat, J hat, K hat form, this would be just -3 I hat minus 2 J hat. For B, I would have +1, 2, 3, 4 in my x direction, and I would have -1, -2, -3 in my y direction, and this would just be 4I minus 3J. The magnitude of A is going to be the square root of the squared of these terms summed together. So this ends up being the square root of 9 plus 4, which is radical 13. B would be the square root of these terms, and you probably know already that this is just going to be 5, right? Because it's going to be a 3, 4, 5 triangle of some sort. Our dot products again. So if I do A dot B, it's going to be AX, BX plus AY, BY. So AX is -3, BX is 4, -3 times 4 is -12. AY is -2, BY is -3, -2 times -3 is +6, and then -12 plus +6 is -6. And again, these dot products work in 3 dimensions as well. Actually, the most reasonable place to use these cross products and dot products is in 3 dimensions. And so for these, since I have a z term, if we do the first example, if we do A dot B, this is going to be AX BX plus AY BY plus AZ BZ. So for this one, it would be 3 times 2, which is 6, plus 4 times 1, which is 4, plus 5 times 2, which is 10, which is 20. For number 2, where we have C dot D, this would be 3 times 1, which is 3, plus 2 times 1, which is 2, plus 4 times 1, which is 4, which would be 9. For F dot G, I would have 4 times 3, which is 12, plus 5 times 2, which is 10, plus 7 times 10, which is 70, which gives me 92. And then finally, for whatever reason, I went back to A and B again. This is as far in the alphabet as I can go, I guess. And I have -1 times 1, which would be -1. I have -3 times 3, which would be -9. And I have -2 times 2, which would be -4, which gives me -14. So on the midterm, there are 13 vector type problems, and then the other part of your midterm will be the performance part, depending on which class you're in. Good luck.